Good afternoon, everyone. I'd like to welcome all of you to today's webinar on an introduction to CEProTECH, Center for Electrochemical Processes and Technology. I am Damilola Daramola, Dami for short, the Assistant Director for Technical Business Development at the Center, and I will be moderating today's session. This webinar is co-hosted by Professor Jerry Botte, the Center Director and Chemical Engineering Professor at Ohio University, and Professor John Widener, the Chair of the Chemical Engineering Department at the University of South Carolina. CEProTECH is a National Science Foundation Industry University Cooperative Research Center housed at Ohio University. Today's webinar will present the center's capabilities and membership benefits, as well as the synergy offered by the potential partnership with the University of South Carolina. As the moderator, I will be keeping track of all written questions through the chat function of the WebEx. These written questions can be provided at any time. However, verbal questions will be taken at the end of the webinar. Finally, this webinar is being recorded for those unable to attend the session today. As such, we ask that you please mute your phones and computer microphones while the presentations are going on to reduce any background noise. Without further ado, I will hand over to Dr. Botte.
Is it going? Thank you, Dami, and good afternoon, everyone. And one more time, welcome. My name is Jerry Botte, as Dami said. And the outline of what we're going to be talking about today is an overview about CEProTECH and what is the value proposition that we offer to our members. We're also going to be joined by Professor John Widener from the University of South Carolina, who is going to address the research expertise and the benefits of the collaboration with the University of South Carolina. Once we finalize that, I'm going to let Dr. Daramola also give you an introduction to our webpage where you can find more information, and finally we'll address questions and answers. So let me start first by describing the NSF I UCRC program. Basically, this schematic, and you can see my pointer moving on the screen, illustrates how the program works. It's one of the oldest programs of the National Science Foundation. It's been around for 33 years, and it funds fundamental research of interest to companies, but it's a very interesting program because it basically is driven by the industry needs, which basically help us develop technology roadmap to address some of the challenges of the industry members. And as so, the university members are charged with providing or generating a portfolio of research projects to address the industry needs. And this portfolio of research projects is developed in collaboration with the industry, participation of scientists, faculty, etc., expertise. And in return, the National Science Foundation also puts funds to help with the administration of the center per se. Members pay a membership to be part of this program and get to share IP and licensing rights, and the university partners had certain bylaws in terms of results for publication, for academic dissemination and publication. So that's an overview of the program in general, and it's been a very successful program for the National Science Foundation. In fact, this slide that I'm showing right now illustrates the statistics according to NSF in terms of funding, students involved in the program, the centers that exist, and the sustainability. One of the very important aspects of this program is really the involvement of graduate students in these programs, which then are hired by the companies. So this is really a direct way to transfer the technology directly to the industry members of the consortium. There are approximately 61 centers nationally with sites. In order to become a center, you need to demonstrate that there is no overlap with any other centers. So in fact, this is the only center for electrochemical processes and technology, and today we are participating in this webinar and also to show the capabilities and the participation of a potential partnership with the University of South Carolina. The next slide talks about the mission of CEProTECH. So what we're basically doing is we are looking at how electrochemical technologies can play a role to provide transformational solutions to chemical and biological processes. So in order to increase manufacturing capacity, energy efficiency, reduce water consumption, emission, and operational costs. And we are basically the center per se, focused in combining electrochemical technologies with classical chemical and biological processes, but also with electrochemical technologies per se. Moving to the next slide illustrates the way or the approach that we implement within the center. So in the center of the slide, in this green box that we have here, we have the challenges that we are addressing. So we're currently focusing in challenges associated with water sustainability, energy storage and conversion, sustainability of resources, process efficiency for manufacturing. And I'd like to start with the box on the right-hand side because this center basically focuses in very fast transfer of technology for manufacturing and how we address that because companies are involved since the beginning. It's been our tradition of continue talking to companies and discussing what are the areas of importance that are affecting their capacity and how we can provide solutions. And in order to do that, we rely on different techniques all the way. We could start with all the way from first principles to mathematical modeling of a process, go farther for synthesis of materials, characterization, in situ analysis technique, as well as rapid prototyping. And so we have a way of how to balance all these areas simultaneously and directly providing the expertise to the industry members. The center scope is basically split within different clusters, and in here we're showing 5 different clusters in energy storage, water sustainability, energy conversion, electrosynthesis, and advanced materials. And if you notice, the bullets that are included in each of these boxes are really areas in which we have, after our collaboration and discussion with different industry members, these have been areas that have been highlighted by companies of areas of interest. So our job has been to develop a portfolio of projects to address these areas. And one thing that is very, very interesting is the fact that you can see here that there are a lot of bullets because there are a lot of needs from the industry, which is really good. And the more areas we can address, with more companies participating within the center. And so then in order to address these areas, the center operates with a team of scientists, engineers, and faculties. Here you could see on the left-hand side a picture of me, and on the right-hand side, some of the people who support me with the administration of the center, Lisa, who is the industry liaison, and Damilola Daramola, who is the person who is with me in the webinar today. And in terms of scientists and engineers, we count with faculty participants of the center, as well as scientists and engineers, which are permanent staff of the center, so that we can support the needs of the industry as well. In addition to the faculty and staff, we also have support technicians, and approximately around 10 graduate students are affiliated with the center, one way or the other. We have a lot more graduate students, but of course the involvement of these students depends on how many companies are members of the center. Our expertise goes all the way from modeling to we have dedicated scientists for instrumentation and characterization, material synthesis, and mathematical modeling and design of electrochemical reactors, as well as microfluidic cells. Here are some examples of the current members of CEProTECH. We have diverse pool of companies, and all the way from chemical companies to companies who are in the automobile business, as well as electrochemical technologies companies by themselves. And as explained earlier, the portfolio of research projects varies depending on the companies who are part of the center. I would say that the way we operate in a yearly basis, we develop a portfolio of research projects of about 15 to 20 research projects that then these companies get to prioritize which ones are going to get funded. So up to now, you can see these are some examples of the projects that are being funded, and we have projects that go all the way from new in situ spectroscopy techniques so that we can have a better understanding of what's taking place at the electrolyte interface, through processes such as lignin conversion, evaluation on the CO2 reduction mechanism, and wastewater treatment technologies, as well as fuel cell projects in the area of alkaline fuel cells with an emphasis on ammonia fuel cells as of today. And the projects, we can only share titles because they are part of the proprietary portfolio of the members of the center. According to the bylaws of the center, new members have access to the technology, and we have some bylaws that allows members to have a look back at projects that goes up to 2 years, I believe. How to become a member? Well, this is a membership center, and basically we're looking for full members, in which the membership is $50,000 per year. And there are several benefits of this membership, which includes a non-exclusive royalty-free license, and they're more specific about this agreement, which is available in the webpage. And before the Q&A, as I mentioned, Daramola will illustrate where to get access to this document so that you could have it and read it and evaluate it. Also, for small companies, we offer the option of an associate member, and that gives them certain rights as well, as they are described in this slide. Then, what are the benefits from being part of the CEProTECH? These benefits that I'm illustrating in this slide are basically what our company think, what are their members of the center. So obviously there is the research value that is provided to this to the members. In addition to that, there is a very good leverage of the funding for basically, as an example that I will show in a couple of slides, you will see that for every dollar that is invested, companies are getting about $11 in return. Also recruiting the next generation of graduate students specialized in electrochemical engineering, and the relationship with faculty, other industry members, and it's really been an excellent catalyst for teaming for major bids. We have examples of a couple of projects that started within the center and that led to $1 million co-investment from other opportunities, in our case within the state of Ohio and within the U.S. Department of Energy. So there is really a good way to leverage the expertise and get some seed funding for major initiatives. As well as there are other programs from the National Science Foundation that are available for our industry members just for being members of an NSF I UCRC. So in terms of the return of investment, this calculation is based assuming 5 projects under the center. And you can see typically with a membership, we're talking about an investment of $50,000 project. The overhead of these projects is basically limited by the National Science Foundation. So all the funding really goes to the project, and the contribution of the National Science Foundation helps with the overhead cost of the center. And so typically, just to give you an idea, a classical project of $50,000 will be equivalent to at least $110,000 per year if you include all the other overhead that are included within university plus other expenses. And when more companies are part of the center, then basically we have 5 projects being funded. The companies are having access to over $500,000 in research with an investment of $50,000. So that's what these numbers illustrate here. So more benefits about the center. Particularly today at Ohio University, the center is located in a dedicated building, which is basically roughly about 20,000 square feet. We have an infrastructure of over $10 million in advanced equipment, and with a lot of in situ spectroscopy and microscopy techniques that have been developed and mastered for different processes. I still remember that the area of in situ electrochemistry also requires research according to the electrolyte and the conditions of the system. So it's not a standard cells that you basically can have off the shelf. It requires some research. We also have a high resolution transmission electron microscopy with the capability of in situ electrochemistry. We have the capability of electroplating, prototyping, battery fabrication, testing, fuel cell fabrication, among others. And it is a benefit of being part of the center that the members have priority access to these facilities. Members have the option to come here and operate these facilities at rates that are part of the membership agreement, and that also they can look at these facilities and schedule time to come or see analysis if they're interested in other areas in addition to CEProTECH, are basically what we call discount rates for being members of the center. So I think that basically at the high level provides some of the benefits of the center, which goes all the way from research to facilities, to know-how, to access to resources, to collaboration, to expanding the network. And now I would like to let Dr. Weiner talk about what are the areas at the University of South Carolina and how we can expand this collaboration. Dr. Weiner?
All right, thank you, Jerry. So yeah, my name is John Widener. I'm the chair of chemical engineering at the University of South Carolina. And I'm going to give a brief introduction to some of the folks that work, that I collaborate with. We have a very large Center for Electrochemical Engineering in multiple departments. One of the areas that we bring some strength to is in the area of fuel cells and catalysis, material development and characterization, and mathematical modeling, which is a complement to what Jerry and her group does as well. So my area, I have some projects funded by DOE on hydrogen production, and we also are working with a variety of folks on fuel cells, electrocatalysis, modeling, and so on. Vat Shimpali is a research professor in my group, and his expertise is computational fluid dynamics, particularly on fuel cells, but also other devices as well. Okay. Two other leaders, international leaders in the field, Branko Popov. He probably has the most diverse set of electrochemical experiences. He's an expert in corrosion. He's recently published a book in that area, and he's used that expertise in fuel cells and stability of catalysts and so on. He's done a lot of work with DOE on developing catalysts for fuel cells, a lot of work in battery development, electroplating, and other kinds of power sources. And then Ralph White is internationally known for his work in batteries and fuel cells, electroplating, particularly in the mathematical modeling of those areas. All right, next. So those four in chemical engineering, but we also have a number of folks in other areas. Kevin Wong and Jinyu Wong are both in mechanical engineering, so they bring more of a mechanical engineering flavor. Kevin is particularly strong in high-temperature materials, in solid oxide fuel cells. Jinyu is a mechanics durability specialist, both in PEM fuel cells and solid oxide and composite materials. Next. And then there's a number of other folks that would be involved depending on what kind of projects. Frank Chen in mechanical does a lot of work in solid oxide fuel cells. Xiaodong Zhou does both PEM and all, but he's a high temperature materials person. Brian Benzowitz is in chemistry. He's an expert on developing new membranes, particularly high temperature or higher temperature polymer membranes like PBI membranes. And then we have a very strong group in heterogeneous catalysis. John Rigobudo and John Monnier do a lot of catalyst synthesis and characterization. Jochen Lauterbach is an expert in high throughput catalysis. Chris Williams and Donna Chen do a lot of spectroscopy. Donna's in chemistry. And the reason, of course, that's important in the area of fuel cells or electrochemical reactors, catalysts are particularly important. And so we are also leveraging another IUCRC. So on the next slide, I just have one slide. Oh, I'm sorry. So I've got a slide on where we're housed. Most of the people that you saw on those previous slides are housed in a new building on the upper right-hand corner called Horizon. and probably 3/4 of that building is dedicated to catalysis and electrochemistry. Then the chemical engineering department is housed in the lower right-hand corner in Swearingen Engineering Center. We have a number of facilities there, both catalysis and electrochemistry that are housed there, as well as a variety of labs there. And the center one is just an example of a lab in the Horizon building. And then we have a spectroscopy center housed in the chemistry department. So I was going to say on the next slide is another NSF IUCRC that John Rigobudo, who's pictured in the left-hand side of this picture, he runs a center. It's about a year old now on rational catalyst synthesis. So they're developing particularly bimetallic catalysts, supported catalysts, what you'd see in fuel cells, but they look at it for applications ranging from pharmaceuticals to biofuels and so on. But they know how to put very precisely metals and bimetallics down on all sorts of substrates, including carbon, and so we've looked at them for fuel cells and electrochemical applications. And Jerry may want to comment, but there are programs within NSF that you can leverage some of the work in other IUCRCs, and so this would be an example of a great collaborative effort. So that's the reason we're anxious to be a more formal partner of Jerry's center. And that's all I have.
Thank you, John. And now we're going to pass it to Dami to talk about more information available.
Thank you, Jerry. Before we begin with the Q&A session, I'd just like to point out some ways in which you can get in touch with the center for additional questions or comments or discussion. First, you can do that by visiting our website at www.CEProTECH.com. You can also send an email to CEProTECH@ohio.edu. And finally, there's an opportunity to preview the membership agreement via our website. So when you go to CEProTECH.com, in the top menu, you will see home, mission, Epson, facilities, researchers, and membership. Once you hover over the membership link, a drop-down menu will come down, but you click on the word membership, and it will take you to the next page, which would look like this, and you can click on CEProTECH membership agreement form. So that's a PDF document that will allow you to preview the membership agreement for this particular center. And on that note, I would like to thank you all for your attention today, and we will take any questions you have over the phone.
So it's Trent Moulter with Sustainable Innovations. I've got a couple of questions.
Hi, Trent. You can go ahead.
Yeah, so first question is, how long has the center been around?
The CEProTECH has been around, established for 2 years. Before that, it gets 1 year to be established. So basically, you have 1 year for what is called planning, and then we've been around for 2 years. We're on our 3rd year.
I see.
Yes.
Okay, and what's the relationship with South Carolina at this point?
What we're looking at is expanding our network of collaboration, and initially we're looking at potentially South Carolina to become a site of the center to bring value to our members who will, for instance, will be interested in PEM fuel cells, which, as you could see from the discussion from Dr. Weiner, has shown a strong background within University of South Carolina as well as other projects. Myself, I graduated from the University of South Carolina, and my advisor was Professor Ralph White. So I originated myself from mathematical modeling of lithium-ion batteries, but once I established as a faculty member, I explore areas of electrochemical technologies, given my previous background as a process engineer in the petrochemical. So that goes a little bit to my background. So there is already some connection in between Ohio University and University of South Carolina.
So there's a formal process, Jerry, right, for the NSF to get us involved. So right now it's to become official, there are steps that we need to follow.
Yes. So there are steps that we need to follow for South Carolina to become an official site, in which one of those is that we are able to bring members through the University of South Carolina as well.
Okay. Yeah, that's what I was going to ask. And I've been a part of an IUCRC before, and, you know, an interesting process is always how do you choose priorities for projects on like an annual basis? So what is your process?
Yes, great question, Trent. So we rely a lot in our IAB. You know, the IAB is basically the heart of the center in terms of the activity and how involved they want to get. So we have set up bylaws in which we interact often with our IAB members. We call them sometimes individually if they want to, sometimes by meetings, phone calls, but we have discussions in, for instance, in the spring meeting, we have discussions and sessions of brainstorming of new areas of priority for the members of the center. And then within that, we develop a portfolio of projects in which, you know, very short, like a one-pager that we send for the members to start looking at those, to narrow down the scope and developing a little bit more farther along official proposals to be submitted within the center to help our faculty, researchers, and scientists to address some of their questions in advance. So, so what I mean is there is the direct involvement into even coming up with the priorities as well as brainstorming sessions that take place during our meetings, spring meeting and fall meetings.
Okay. That's all the questions I had.
Okay.
Thank you, Trent. Any other questions?
This is Rick Barant. I'm wondering if this document will be distributed after the meeting.
Yes, we can distribute the
document.
The document, the PDF, and also is being recorded. So we will provide a link with the presentation as well, so it will be audio as well for people to have access.
All right, thank you very much.
You're welcome.
Thank you, Rick.
And what is the timeline, Jerry, on some of these? Your next meeting is in May, is that correct?
Yes, our next meeting is going to be on May 13, and we expect that new members to join the center to start April 1st, which is basically the start day of the membership agreement. So memberships are basically open on an annual basis because that gives time to being able to execute projects. So we also work very close with companies who want to join the center to develop a scope of projects that will be of interest. So as part of our bylaws, our current IAB members, they understand that they want to get more companies involved, so to interact, have better interaction, and also to get more access to more projects because of their dollars being leveraged, right? So they basically will design a path in which we can work with a scope for the project just for new members to make sure that their needs are being addressed as they are new members. So we're looking at, back to your question, John, we're looking at memberships to be signed so that they can start April 1st of 2016.
Jerry, this is Lauren with Ingenuity, and I'm just wondering what the next step would be for those that might be interested in becoming members. Should they go through either Dr. Widener or yourself and just get in touch with either of you?
Yes, so what we will do is if we have a member who is interested on joining, they should contact, I would say, send an email to me, copying Dr. Widener, both of us, and then if they're interested in joining the center, then we can walk you through the membership agreement, and then we'll work on potential scope of project if the capabilities are at the University of South Carolina or within Ohio University. Once we are a whole center, remember this center is treated as a center, so everything will be like a combined center at that point. Initially, the first step for the University of South Carolina will be to be as an affiliate university, with the intent that at some point it will become a site of the center officially through the National Science Foundation. But for that, there are certain requirements that have to be met, in which this is one of them, basically.
Okay, thanks.
Okay. Well, if you go ahead, then.
I guess if there are no other questions, again, the goal here is we've recorded this webinar, and it will be available almost immediately after the webinar, which will send a link to those of you who are attendees. Lauren and I will get together after this to send out that link to make sure you get it. And with that being said, I think.
Yes, well, I want to thank all the participants and Dr. Weiner as well as you. This has been great, and I hope that this collaboration crystallizes and that we have more partners, and then we can have a live interaction in this coming IAB meeting in May.
Yeah, and certainly if, as you pass this around and others listen and you develop, have additional questions, please don't hesitate to contact either me or Jerry. We'll be happy to follow up.
Absolutely.